Hi, my name is Greg Sullivan, and in this program we're going to be working with this model of a Zero fighter plane. We're going to approach this as a technical director, add some rigging so the flight surfaces behave correctly, add some particle dynamics, add some rigging for the landing gear, and some soft bodies so that when they hit the ground they'll compress. And we're going to do a couple of other fun things that'll make this really easy to work with from an animator's perspective. Alright, so let's get started. Okay, the first step is to load your object into Modeler. We've already done this. It's a very nice model. You can see it's very detailed, very well built. But one of the first things we're going to find out about this model is that it's way out of proportion. So if you look down here at the grid size, you can see it's 32 feet per grid. And you can see that that means this is 32 feet, this is 32 feet, this is 32 feet, which gives us an enormous airplane. There's any number of reasons this could have happened. It could have been modeled by someone who just didn't know the right measurements. It could have been modeled from photographs and someone didn't do their homework. It could have been built in a different program, any number of reasons, but it's something we need to fix. So the first thing we need to do is find out what the measurements should be. Quick bit of internet research and we can find that out. I've already done the Google search. And I have the information on the Mitsubishi A6M0 right here. Here are the dimensions. We only need one. In this case, we'll take the length. It's 29 feet, 9 inches. Just remember that. Okay, so we know that the aircraft is supposed to be 29 feet, 9 inches long. And the fastest, easiest way to get that dimension is to create a box with that dimension. So because layers 1 through 10 are filled, as you can see, with parts of the airplane, we're going to go to our 11th layer and create a box. Shift X for box, N for numeric. Enter 29 feet, 9 inches into the depth. And this is going to give us a box that is the appropriate length for our aircraft. As you can see, go back to our first set of layers, the layers 1 through 10, and shift select all of the layers so that they're all active. We can manipulate all of those parts at once. Then go over to your second set of layers and select the lower half of the box so that you have it as a background layer. That way you can see it, but you don't have to manipulate it. Hit A, get everything into your view there. Hit Shift H. Now go down here to Mode and set your mode to origin. That way you're shrinking the object uniformly from the center point in your scene. And keeping an eye on your right or left viewport, drag down until the length of the aircraft is the length of your box. Because we're using Shift H, the scale tool, all the other dimensions will take care of themselves. So I'm going to bring this up as my primary view. And you can see we still have a long way to go. This airplane was huge. I keep hitting A to center everything in my scene, or G to point where I want to point. Just viewport manipulation, good stuff. Alright, now if you were working for the History Channel, you'd want this to be exactly accurate. I'm just going to get it within a couple of inches. And the reason you want to model to scale and do this research is several reasons. The first reason might be lighting. The lighting effects in Lightwave are calculated on real-world measures. So if someone's going to use some radiosity or something like that, they'll need your model to be the right scale. The other thing is the modeler working down the hall from you may be working on the pilot. The pilot's going to be 6 feet tall. If your airplane is 1,500 feet long, he's not going to be able to fly it. He's going to be too small. So there's a lot of good reasons to build to actual real-world scale, and a little bit of internet research will make you go a long way in that direction. So now that we've got our plane to roughly the right scale, we can go to our 11th layer. We have all of our primary layers selected and our little size box in the background, so we can just hit the quotation key to swap our layers out. Hit delete, box goes away, swap them back, and we now have an appropriately sized plane. So this is a good time to do our first file save. Incremental file saving is incredibly important. All programs this complex tend to crash once in a while, no matter how well they're written, no matter how well you maintain your hardware. Every once in a while, you're just going to crash, and you're going to kick your own butt if you haven't saved the scene incrementally. Lightwave 8 has this really nice feature, Save Incrementally. So you hit just Shift S, and it will automatically save the scene and add an _V and a version number 3-digit serial. So now that we've got our plane to the correct size, we need to start looking at the parts of the airplane. Let's check out the different layers. We have what's basically the fuselage here. Everything on the airplane that doesn't move, more or less. Second layer is the prop. Very nice, separated out perfectly. Third layer, canopy top, in case we need it. That's your rudder. Let's just put the fuselage in the background so you can see where all these parts fall. That is apparently the left side flight surfaces. This is an aileron, and this is a rudder. Here and here, aileron, rudder. These do not move with each other. These move independently, so they'll need to be placed on separate layers. And if you look at layer 6, you'll see it's the same thing. The right side flight surfaces are grouped together. They shouldn't be. We'll fix that in a moment. The 7th layer is the left landing gear, the wheel itself actually. The 8th layer is the other wheel. And then you've got your left and right landing gear hardware, respectively. So the first thing we need to do is address those flight surfaces. We'll need to move the aileron. We'll start there. Select the aileron, just select a few polygons and hit the open bracket key. It'll select the rest of the surface for you. Quick Control X, that's a change from Lightwave 7 in case you're curious. You can choose to use the old command set if you'd like, but it's probably best to not do so and get into the habit of using the new command keys in case you move to a new computer. Control X, Control C, Control V, the standard Windows keys have now been set up to work with Lightwave. Just something to be aware of. So we've cut our object and we're going to go back to that 11th layer because we need to use it for storage. Control V, we'll paste in our left aileron. We're going to go back to layer 6 and now we just have half a rudder. Now what you need to know about rudders is they don't move independently. They move with each other. So we're going to place the other half of the rudder from layer 6 with its brother on layer 5. And the rudder control surface will be ready. Now we've got the right aileron all by itself and the left aileron all the way out here in the boonies in layer 11. Layer tools in Lightwave 8, very powerful. We can do an insert layer before layer 5 so that our two ailerons can be on adjacent layers. So under View, Layers, Insert Layer, conveniently associated with the Insert key, it'll insert a layer. Now everything has been scooted up a layer and we have a blank layer. So let's go to what is now layer 12, grab our right aileron, cut it. Now I didn't have to select it because it was the only thing on the layer. Go back to our new blank layer and insert it. So now we have fuselage, prop, canopy, rudder, our horizontal control surface, or our elevators. This is that I've probably been calling elevators for rudders for the last few minutes. Those are elevators. Our left and right ailerons, left and right wheels, right landing gear, and left landing gear. So we're now set up with everything where it needs to be. If we were to take this into layout right now, we would find that all the naming is in French. So we're going to start by going to Layer Settings, still under View, over here under Layers, Layer Settings. We're going to name this, right now it's named Core. We're going to call it Fuselage. I'm just going to go through all the layers and name them. This is the prop, canopy, rudder, elevators, elevator singular, left aileron. We're going to call this aileron because it's the first one we've had that there's more than one of, and it's left and right respectively. We're going to give this a dot name. We're going to name this the aileron, A-I-L-E-R-O-N, and we're going to go dot left. It just breaks it apart. It's a good thing to put that together so your names are all together, and then you have a dot and top, bottom, left if there's more than one of them, or a serial number if there's 25 of them if you're working on something with that many redundant parts. You can use a dot and underscore, whatever works. And it's also a good time to point out here that the parenting is set to fuselage. Whoever built this model already took care of that for us. That means when we take this into layout, these parts will all be parented to the fuselage. It's good. We're going to end up changing that, but it'll save us some work on the parts that we don't mess with later. Moving down the line, another aileron, aileron.droit. I'll save myself some typing. Aileron.right. That's the left wheel, or like I had been saying, wheel dot left. Parent that to the fuselage. Wheel dot right. Now when you're working on a model, don't get lazy and skip the naming of things. It'll drive you nuts in layout when you're trying to find find your parts and you didn't name them appropriately in Modeler. It'll save you a lot of headache to do it right now. Invest the time, you'll thank yourself. Or someone else will thank you, and that's always a good way to get a raise. Now here all by itself, our last little piece of hardware, gear dot right. Okay, now I'm going to hit Shift S. That's going to save my increment. If you look up here, 0_V002. We're on to our second version already, and all we've done is work out the layers and swap things around. Okay, now having named all of our parts appropriately, we want to do one last thing before moving into layout. We want to select all of our parts with Shift and selecting the upper part of the box, so we have everything all together. Looking over here in our right view, you can see that the center of our airplane is a little bit after the cockpit and in the center of the fuselage. That's actually pretty close to the center of gravity, and so we might want to leave it there, but we're going to do something different in layout. So what I want is the gear to be at 0 on the plane, so 0 equals on the ground. Press G, zoom in. Just get those landing gear pretty close to being on the ground. Right there. Okay, so now our model is above the grid, probably where it should be. With all of our layers still selected, we have one last thing to do before we save up, head over to layout. Our airplane is facing in the -z axis. We can see that by going to the top view. You can see +z here, -z here. The problem is when you do an align to path or anything like that in layout, you're going to want to point to the +z axis. It's a really helpful feature. Even if you don't plan to use it, it's always good habit to have anything like a vehicle pointing in the +z. So with mode still set to origin and the top view selected, put your mouse over the top view and hit R twice. Each time you press R, it'll rotate at 90 degrees. We're now facing the right direction. Save the object, jump over to layout. And now you can see our object is above the ground plane. So one of the first things you need to think about in a production environment is time. Your time is costing whoever is paying you money. The computer you're sitting in front of is costing whoever is paying you money, if you're thinking in a production environment. If you're freelancing, you can take your time and enjoy setting all the settings to 11 and really, revel in being an animator. But if you're working in a production environment, you've got to keep moving. First thing we're going to do to save us some time is we're going to turn down the subdivision levels on all of these objects. This is modeled with subdivision surfaces. For those of you not familiar, it's a way of creating smoother surfaces from rougher surfaces, but it results in a lot of computation time for a video card. So bring up your properties, and you can see your display subpatch is 3, and your render subpatch is also 3. That just means for each polygon there'll be 3 subdivisions. Display means that's what you look at when you're working. Render means what comes up when you're rendering. So don't touch rendering. That's somebody else's responsibility. Touch the display. Turn it to 1 or 2, depending on how good your video card is. I'm going to set it to 2 on this system. And you can see very subtly that the plane looks a little less smooth around the edges, but it still looks pretty good. And it's moving a little more smoothly. We're getting a higher frame rate from the video card. So what you're going to want to do is bring up the property panels for all the subdivided objects and set the display settings down as low as you can stomach looking at them, but as high as your video card can handle. So that's a judgment call, and it's really going to save you a lot of time spinning the model around. I've already taken care of all that now, so we're going to go back and we're going to start seeing if there's anything else we need to do. We need to save the scene. File, save scene as, because we haven't done it yet. It'll drop you into the scenes directory of your content folder. Give this a scene. Name, we're going to call it rigged 0. Spell out the word 0. If you have the number 0, it's going to confuse somebody down the production pipeline, trust me. Return. Okay, so we're all good to go. So we've saved our scene. We have now made sure it's above the ground plane. We've rigged it how we like in Modeler. It's time to start thinking about how this is going to work. Okay, now that we've got layout set up and ready to go, we need to start talking about rigging. Rigging is the act of setting up a model for animation. You need to do your homework to do rigging. You need to learn how your subject behaves. If you were rigging a human, you'd need to know how the bones interact. You'd need to know where they bend. You'd need to know these things. In an airplane, you need to know what parts move and what they do. And so we've got left and right ailerons here. We're going to learn that they move in opposition of each other. I've already done my homework. Elevator moves up and down. Rudder moves sideways, controls the plane. These are things we're going to need to set up for our animator. We're also going to set up the landing gear, and we're going to set up the propeller. So let's get started. The first thing we need to do is think about where things rotate from. Right now, all the pivot points are at the 0 axis. So everything you select has its pivot point at 0, 0, 0, 0. And if you select an object and rotate it, you'll immediately see why that's a problem. That's no good. Same problem here, same problem all over the model. So the first thing we want to do is move the pivot points. And to do that, we're going to want a quad view. So hit D for display and select quad. That'll bring up your 4 different views. I like to work in front-facing wireframe and everything but my 3D view. Just a personal preference. You can work in whatever you'd like. And we're going to start with the left aileron. Now, we're going to move the pivot point under Modify, Translate, Move Pivot to where we think the hinge would be on this object. So think about how this would physically operate. So we can tell by looking that this would move from the front edge, and let's just place it toward the center. We can put it wherever we'd like really, but let's put it toward the center. And now we see if we go to rotate it, that it's going to move appropriately. More or less appropriately. We'll address the fact that it's moving on the wrong axis in a moment. Let's look at the values for where we just put the pivot point. Go back to your Move Pivot Point tool, look down to the pivot position. -12 feet, 3.276 inches. We don't need that kind of resolution. Lose everything after the decimal. Delete it, don't press 0. You'll add 30 inches and that's no good. Do that for all of these values. Keep in mind this is for this application only. There will be times when you want those decimal points there. This just isn't one of those times. Now make a note of all of those. Write them down on a piece of paper, open up Notepad, but you're going to want those values. So I'm going to pop them into a Notepad right now that I have open. Just write them down. -12 feet, 3 inches. 5 feet, 6 inches. 3 feet, 8 inches. Okay, now we're going to select the right aileron. And you can see that the pivot position is 0, 0, 0. So go to your Move Pivot tool, make sure it's selected. If you don't have it selected, you'll accidentally move the aileron, as you'll probably discover on occasion the hard way. So cut and paste your variables into the pivot position. Be sure to hit Enter after each one. Just hitting Tab doesn't work. All right, so we're immediately going to notice a problem. Our pivot point is in the middle of the wrong aileron. That's because we use the exact same coordinates. Obviously, your x coordinate is wrong. It needs to be a positive value. That will put it onto the other wing. So now both of our ailerons are rigged. Okay, I've already gone and set most of these points up. You go ahead and take the time to do that yourself. Once you think you're done, grab each of the parts, give them a quick rotate, and if they feel like they're moving as they would on the real airplane, then you've rigged them up correctly. 2 special points. The prop. We're going to set that one up together right now. Why is this one special? Well, it's rotational. So we're going to make a point of putting this in the exact center of the propeller. The reason for that is when it rotates, it'll rotate off balance like an imbalanced car tire. It'll wobble. We don't want that. So zoom way in, get right up in there, and just put the pivot right in the center, and it'll rotate exactly as you want it. The other point is the fuselage. The fuselage, the pivot point is at 0, 0, 0, 0. We're going to do some tricks later to address some different problems with the fuselage, but for now what we're going to want to do is we're going to want to put the pivot right where we think the center of gravity is, where we want the plane to rotate around, what feels most natural. Realistically, it's just a little above and beyond the back edge of the wings, or just below and behind the cockpit, whichever way you want to think about it. Grab that, give it a quick spin, and see how that feels. That feels a little high and back to me. I'm going to move it down and forward into the wings a little bit. Okay, so we are now rigged with all of our pivot points where they need to be. Okay, now we're going to start adding some nulls. Nulls are incredibly powerful for something whose name means nothing. Null means nothing, but you can parent things to them, use them as control points, use them with hypervoxels, lots of important things. What we're going to do is use them as additional control points for all of our control surfaces, and I'll explain why right now. Let's start with the ailerons. Okay, so if we look up here, we can see that the aileron pivot is where we wanted it, but the rotational axes are not right. You can see this is kind of tweaked here and here. I'm going to put that back. We're going to fix that by adding a null object to our scene. We go over here under Items, Add Null. I've already done that. There's one down here. And we're going to move this null up to where our previous pivot point was, more or less. Just think about it as if you're putting the axis back again. Except this time we get it where we want it, and we're going to rotate it so that the null is lined up with the rotational axis we want. About 10 degrees. We'll zoom in real close, make sure it looks about right, maybe a little less. Bring it back, we'll call it 8.8 degrees. Now we're going to start messing with our parenting. We're going to select the left aileron, and let's take a quick pop over into Options, hit O for Options. Look over here at Parent in Place. Make sure this is checked. Parent in Place should be on. Now, select the left aileron, hit M for Motion Options, and right now it's currently parented to the fuselage. We want to parent it to our null. Doesn't look like very much just happened. That's good. Select the null and rotate it. Now that aileron is behaving correctly. See, we've got going on there on both sides. Now, in Modeler, we named all of our items correctly. So what we have here is a null, just called null. We're going to add a lot of nulls. We need to give that a name. We could have named it when we added it. That little pop-up box came in. I'm going to give you a quick look into the scene editor, though. So just click Scene Editor, Open. Find your null, right-click on it, and choose Rename down here under Manipulate. Let's call this aileron left dot root. Good name. It's the root of the left aileron. So if you grab aileron left dot root and rotate it, you're going to get that rotation you want. Now let's go back to the scene editor, and you can see this little arrow here means that there's something parented to our aileron left dot root. It's the aileron, of course, but we don't want to ever accidentally grab the aileron, so we're going to lock that by clicking the little lock icon. Now, every time you try and grab the aileron, you won't be able to. That's a good thing. We're actually selecting the null, which is exactly what we want. Okay, so let's add another null. Items, Add Null. We're going to name this one at this point aileron right dot root. Adds it to the root. Okay, I've gone ahead and done the trick we did earlier with the ailerons where I cut and paste the positional information and inverted the x-axis, so now my null is exactly where the other null is, but on the other wing. Now we need to do one more thing. We rotated the other null, so let's hit Y and look at our rotation on both nulls. Let's compare that. The left null has a heading of 8.8 and a pitch of 11.0. The pitch is accidental. It's not supposed to be there. I added that earlier on accident. Get rid of that, put it back where it's supposed to be. But the heading is 8.8. That's important. Let's go over to our other root and look at that. Let's put 8.8 in the heading. Now that's the wrong way. Negative 8.8 will fix it. Now we want to go in and parent our aileron to that null. Go M for Motion and parent it to the other null, aileron root right. So now we've got both of our items parented. Go to the scene editor and let's lock our right aileron so we don't accidentally select it. Now while we're here, we're going to do something else. Our two aileron roots are out there in space by themselves. As you can see here, they're not parented to the fuselage. So when we move the fuselage, the ailerons are going to be left behind. We're going to do this by dragging and dropping here. It's just another way to do the same thing we were doing through the motion options panel. The more ways you know how to do something, the happier you'll be. So drag and drop those under the fuselage. Now I just accidentally parented one aileron root to the other. You got to be careful. This little line here shows where you're parenting. And there we go. Our parenting is all set up. Fuselage, roots, ailerons. And the ailerons are locked. So now when we grab our plane and move it around, everything comes along for the ride. And when we grab any particular item and rotate it, it rotates the way we want it to. So we're just going to sanity check ourselves here, jump through all the items very quickly, make sure everything's moving the way we want it. Now wait a minute, what just happened? That rotated incorrectly. That's because it was rotating around more than just its pitch. It was rotating around its heading and its bank. So we want to lock those while we're here. Okay, we're going to go down here into the lower left-hand corner, and you can see we've got rotation up, heading, pitch, bank, all lit up. That means we can manipulate all of them. If we click and drag away from our object, it rotates in all axes. We don't want that. We want it to just rotate around the pitch, because now we can click and drag and we get just the rotation we want. So we want to go through all of our objects and quickly turn off the rotational axes we don't want. Okay, I've already gone through and turned off all the unneeded rotational axes, but just to be clear for those of you who might not know what that means, we've got one left to do, and this is the propeller. You can see we've got the heading, the pitch, and the bank all lit up. We can grab any one of these handles and rotate it. We want the bank to be the one we use. This means your airplane is broken. You're in trouble. This means the same thing. We do not want heading and we do not want pitch accessible. So, turn those off. Now we can only rotate it in the right direction. So very quickly, we'll just run through all the different ones. The canopy, for example, has no rotation. We don't want this rotating. It slides. So we've turned them all off. The rudder, just around the heading. The elevators, just around the pitch. The wheels, just around the pitch. The gear, just around the bank. And the nulls for both the ailerons, just around the pitch. The plane can move however we want it to move. So we've left all of those on. Okay, so now the plane is getting very close to usable. We could theoretically animate with this plane now. If I was an animator, I could pick it up, move it around, and I wouldn't be able to do anything especially stupid to it. But taking care of things like rotation on the propeller, the wheels, deformations to the wheels, and animating all those control surfaces to move realistically as it flies through the air, that would be a real pain and something that is better left for the technical director to take care of, so I can just be a creative animator. So we're going to rig this plane up now. Okay, so now we've got everything parented the way it should be, moving the way it should be. We can grab this plane, and if I was an animator, I could start animating a scene. That's all well and good, but there's a lot of things to animate here. The control surfaces, the ailerons, rudders, and elevators, the propeller, the wheels, the wheel compression. There's a lot of things as an animator that I don't want to have to think about. I just want to fly my little airplane around and shoot the bad guys. But if you were to do that without thinking of the control surfaces, it would be a very unrealistic, boring, poorly detailed animation. So we want to free the animator from having to worry about those things. So now we're going to get into rigging the airplane to do these things for the animator automatically. So let's take care of that. Okay, the first thing we're going to do is add another null. Go to Add Null, and we're going to call this one Wheel Center. And let's move this to right between the wheels. Now, what are we doing? We are adding a null that you will use to animate the airplane when it's on the ground. The airplane doesn't animate, airplanes don't rotate around the center axis like we had just seen. They'll rotate around the pivot point roughly between their center front wheels. So we want to put this here. Now we want to take our plane, select the fuselage, motion options, and parent it to our wheel center. Now when we're animating the plane on the ground, we can make sure it's moving from the right location. But there's a problem, because that is not what's going to happen. The back wheel needs to be on the ground. So now we've parented the fuselage to the null, we can set it up to rotate around like it would on the ground, between the tires, and put the tire on the back on the ground. Now when we're animating this for takeoff, you can see that it's relatively easy to do. Another opportunity to shut off some unnecessary axes here, because we don't need to be doing this. If we're doing this on the ground, again, we're crashing the airplane. That's no good. so turn off the bank. We still need the pitch because as the plane gets up to speed, we want that back tire to lift up. And we obviously want the heading because that's what we're putting this null in for. Okay, so we've added a null between the tires. This gives us a problem. When we're in the air, we are going to animate the airplane flying, and the airplane's center of gravity is not between the tires. So we need to add another null. Add another null. Call this one CG. You can call it center of gravity if you're not familiar with CG meaning center of gravity. Move this back to where you think the plane should fly, should rotate around when it's in the air. Just like we did with the pivot point for the fuselage. We can get rid of this pitch I added here earlier for my example. Let's put this back in its resting position. And that's about where we want the center of gravity to be. Now we're going to take our wheel center and parent this to the CG. So now when you want to select the plane to fly the plane, you select the CG. Well, if we're selecting the CG to fly the airplane, we don't ever want to select the fuselage, because that will tear the fuselage away from its nulls and will just cause all sorts of headaches during animation. Best way to prevent an animator from doing something stupid is not let them do it. Let's lock the fuselage. Back into the scene editor. Take the fuselage, lock the fuselage. We can't touch the fuselage anymore. So now, if we were to touch everything we wanted to in this scene, we could only touch the things we're supposed to touch. We're not going to be breaking any rules. Okay, so now this plane has got all of its centers of gravity set up, and we can fly the plane around, on the ground and in the air. Okay, so we want to get to the airplane. We can't, it's locked. We're trying to get to the CG so we can fly the airplane. Luck of the draw, it's this tiny little null buried inside all this other geometry. That's going to be hard. We want to add a proxy object, something bigger and easier to get to. So let's add another null, plane selector. Move this up out of the way. It doesn't matter where you put this. Get this somewhere easy to see, up above the plane, something the animator will be able to easily find no matter which view they're looking in. I've decided that it should go up over this wing, behind the plane. Don't let it get lost in the geometry if you can avoid it. Go to Properties and go to Add Custom Object. We're going to add an item shape. Double click on that. Brings up the item shape tool. What we're going to do is change the shape. We're going to use a pyramid. Why not? Point it along the direction the plane flies, the z-axis, just for fun. Make it 2.5 feet. Again, this is all completely arbitrary. It's up to you what you do here. Label it plane. Easy enough, right? Justify that off to the left, right, or center as you see fit. I'm going to put it out to the front. Draw a line to the CG. Okay? Selected color, doesn't matter. Unselected color, make it something bright and easy to see. I usually use an obnoxious shade of green. And there you go. Okay, so now we've got an object floating in space that we want to be a proxy for our CG. We want to select it and get the CG. Before we can do that, we have to parent it to the CG, because if you do it in the other order, Lightwave will get mad at you. So select your plane selector null, hit Motion Options, and parent it to the CG. Now, they're parented together. Go to Utilities, Master Plugin, and let's add a proxy pick. Double click on that for options. The proxy object is your plane selector. The target item is the CG. Don't click this button. It'll apply a label to the proxy object, labeling it. If you do it on accident, or you were getting ahead of me and you pushed it already, I'll show you how to take that out very quickly. So don't do that, but if you did it, I'm going to show you how to fix it. See how we have two labels here? That's no good. So You go to select the proxy object and click Properties and see how there's two item shapes. Ours is better. Remove theirs. Right-click, remove. Now everything is as it should be. Select this light, or anything else for that matter, and now try and select this proxy object again. Notice what just happened. The plane got selected. The CG of the plane got selected. Not the plane fuselage, not the null. Exactly what we wanted to happen just happened. And when we animate, our little null moves along. So to select the plane, just select the null object. Okay, so the next thing we're going to work on is the landing gear. In a real airplane, you push a button and the landing gear goes up or down. We're going to try and set that up for our animator. All they want to do is deal with a very small control and have the landing gear take care of themselves. So the first step in this is to make sure that our landing gear is parented correctly, which we're going to discover it isn't. Okay, the gear portion you see here is parented to the fuselage, because that's what we parented it to. The wheel is also parented to the fuselage. So if you take the gear portion and rotate it, you leave the wheel behind. So we need to quickly reparent our wheel through the motion panel to our gear. So this is the left wheel. We'll parent it to the left gear. Imagine that. Grab the gear, rotate it. There you go. Okay, so the wheel is now in place. Do the same thing on the other side. Okay, so what we need to do is animate this for the animator. And we're going to notice a quick problem. I'll point this out to you right now. You can't see it very well. Let me rotate the light so you can see under the wing. There's no hole for our gear. Okay, this is an interesting point. The model's not right. This is a production environment. What do? Well, you check with your director. Do we send this back to modeling? Do we deal with it? What do? If you were on the Discovery Channel and you needed a close-up of the gear coming up, you'd send it back to modeling for fix. For our purposes, let's just say we don't see the gear that close up. We're going to fold the gear up into the wing, just make them disappear. So to do that, we select our gear, go to frame 30, make sure auto key is on, and then rotate your gear up into the wing. Get it kind of close. As you can see, it's not going to go into the wing. The space just simply isn't there. Just make sure it's not intersecting through the top of the wing. Going to move that light again. Make sure we're getting what we want here. Okay, it's not coming through the top. And go back under the wing. Okay, so our gear is up. 30 frames. Just like we wanted it to be. Gear goes up. Not the world's best animation. It's okay. Passable. Let's go to the graph editor real quick. And let's just smooth that rotation out. Go to right-click, drag, select your point. Turn the tension up to 1. And let's have it smooth into that rotation. Okay, that's perfect. Now, let's animate the other gear. Now don't go getting ahead of me here because we're going to do something different. We're not going to actually animate this gear. We're going to have it copy the animation from the other wheel. Okay, why would we do that instead of animating this wheel? Well, if we make changes to the other animation, we want it to apply to both sides. These gears work in tandem on a real plane. That's how it's going to work here. And this gives us the freedom to make changes in the future without having to do it twice. So we're going to hit M, bring up the motions panel, and add a modifier. The modifier we're looking for is follower. Double-click to get the options up. Now we want the gear on the right to follow the gear on the left. So select gear left. Okay, let's click continue and see what just happened. Okay, well, the gear fell apart. It jumped to the wrong side of the plane. It's rotating backwards. A bunch of things just went wrong. What just happened? It copied everything from the other gear. It copied the motion. It copied the position, the rotation, everything. We don't want to copy everything. We only want to copy the rotation. So let's go to all these positionals and set the source to none, none, and none. Hit continue. It goes back to where it's supposed to be. Run the animation, it's folding the wrong way. Go back to our follower, and we can see that we want to do the opposite bank. So right now it's following the bank, and it's doing exactly what the other one's doing. We want it to do the opposite. So set a -1 value there. And what you're going to have when you run the animation is the wheel folding up, following the other one. Now, let's make this a little more visually interesting. Go back to your motion options, open up your following controls, and let's set a time delay 0.1. That's 0.1 second. What that's going to do is give it about a 3-frame delay, and if we look at the whole thing, when we run the animation, it's going to look a little more organic. Just a nice little touch. Okay, so we animated the gear. What if the gear aren't supposed to animate at the beginning of the animation? Of course they're not supposed to animate at the beginning of the animation. We want a way to control those. So we're going to add another null. Call this one gear control. I find it's best to name things what they are so you don't confuse yourself later. Move these again up somewhere easy to grab. I'm going to move it out here on the opposite side of the plane from our plane selector. Spend a quick moment to add another item shape so that we can label this gear control. Don't draw a line to anywhere. Set the colors however you want them to be. I'm just going to make them white. I'm going to set the text color to be an obnoxious bright red like I did on the other one. Easy to spot. Make the shape. I'm going to make this a ring, and I'm going to set it across the x-axis. Make it a quick 2 feet, no big deal. And you'll see why I did that in a moment. Okay, so now we have gear control. We're going to add a plugin called Cyclist. Cyclist is great for repetitious things, doors opening, complex animations. We're using it for a relatively simple animation, but what it does is it takes a certain range that you give it, and then at each point along that range, it plays part of the animation. We're going to give this ring a 90-degree limited rotation. So at frame 0, at rotational angle 0, it'll play those 2 wheels at frame 0. At rotational angle 90, it'll play frame 30 and incrementally along the way. So at rotational value 45, the wheels will be at frame 15. Now, why is that so valuable? Well, if you were to have the doors opening underneath the landing gear and then a hydraulic line move out of the way and a very sophisticated landing gear opening animation, you can do all of that with just one null using Cycler. So let's set that up. Select the left landing gear, go to Motion Options, and add Cyclist. Double-click, bring up your features. The cycle controller is going to be gear control. Control range from 0 to 90. It's going to use rotation pitch. So set the pitch angle as the control here. Cycle from frames 0 to 30. That's the default, and that's why we set the gear up to go to frame 30. If you had a really complicated 120 frame animation that you wanted to cycle control, you would set that to 120 right there. So click OK. And nothing looked like it happened. Select your gear control and rotate it along the pitch to 90 degrees. And the gear move. Okay, while we're here, let's take this opportunity to lock the heading and the bank. We're not using them. Now you can just click and drag whatever you want. And you can see the wheels animate automatically without having to select them. And if I do it slowly, they go slowly. That's also important. What if the animator wants the gear to go up very quickly? We did not limit them to a 30-frame cycle. That's just for our use. Okay? So let's go to Motion Options and go over to Controls and Limits. Remember how we set that to a 90-degree arc. We want to limit it to a 90-degree arc. So let's set the pitch limits to 0 and 90 degrees. Now the animator cannot rotate that control outside of its acceptable range, which is good because it means you can't make the landing gear break. Ultimately, it's unbreakable. So we're going to save the scene, another increment. You should have been doing this every couple of minutes. And let's parent our gear control to the CG. So now wherever we move the plane, the gear control will follow. Okay, so we've animated the gear going up and down into the fuselage. What about rotating the wheels? Now, we can do this in any number of ways. We can hand animate it. That'll be a pain, I promise. We can buy an expensive plugin. They're available. You can go find different things on the web that might help, but we're going to use expressions. Very simple expressions. A little bit of math involved. Trust me, I'm not a programmer. You can do this if I can do it, and I can do it. So let's take a look at how we're going to make this happen. All right, so we've got our wheel selected. We're going to start on the left. Bring up your graph editor and select the rotation for pitch and go to the expressions tab. We're going to use the builder here. This is going to help us a lot. People who don't use the builder are very good at expressions, and we aren't those people. I'm going to go up here and select vector magnitude from vector functions, VM, distance, standard. Okay? You can click for description. It'll tell you what it basically does, examples, applications, all sorts of information about what this does. For input A, we're going to select world vector and select the position X of our left wheel. Select choose. Do the same exact thing for the second option. Now, if you're going to read this little grayed out thing, what it says is vector magnitude. It opens the parentheses. It's just a little math function. 0_V003. You'll recognize that. That's our file name. Colon, wheel.left. You'll recognize that. It's our object name. WPOS. That means world position. Open parentheses, another little math thing. Time, close parentheses. So what it's saying is vector magnitude, which is the length between 2 points, of this object at this time, minus the exact same expression. So the return value for this is going to be 0. But that's okay. Click accept, give it a name, left wheel control. Hit create expression. Close the builder, and you'll see over here we have left wheel control with all of those values. Okay, the first thing we need to do is change one of these. This is measuring the distance between the object at the exact same point at 2 different times. I mean, at the exact same time. That value will always return 0. So let's change the second one to 0. Okay, so now what we have is the vector magnitude, or the distance, between the wheel at the current point in time, right here, time, and the wheel where it was located at frame 0, thus our 0. So that's going to give us a distance. That's not going to tell us how much our wheel should have rotated, though. So now we need to do a little bit more math. First thing we need to know is how big our tire is. That way we know how many revolutions to give it. It's an important thing to know. Swap over to Modeler. We have our tire in front of us, and we've got to figure out how big this is. Not only do we have to figure out how big it is, which is relatively easy, we need to figure out how big it is in meters, because expressions like meters, it's just the easiest way to work with them. So we're going to go to our display options. We're going to units, set that to metric. We had it in English earlier. We're going to create a box. We're going to draw a box around our tire. We don't care about the depth, so just do it in the right or left view. Get it as close as you can. And then hit in for numeric. You're going to see that the height is 60.96 centimeters. Our preferred number in expressions is meters, so just move the decimal 2 to the left, and you see we got 0.6096 centimeters. So write that down somewhere or copy it. Select polygons, delete the object you just added. You don't want that on your tire. And hop back over to layout. Now in your expression, here, at the end of the expression, type divided by and paste in your number. Move the decimal 2 to the left. Okay, now what it's doing is it's taking the distance between the current location and the time 0 location. So if you've moved 10 feet, it's taking that number, 10 feet, and it's dividing it by 0.6096 meters. So it now realizes how much tire turning had to have taken place. But it's not going to quite work that way. We need to divide it by 360 degrees to translate that from a distance value to a rotational value. So go to the very beginning of your equation and type negative 360 times, which in this case is shift 8, the asterisk key, not the X. Open up your parentheses, go to the end of your equation, close your parentheses, and we should be done. I hit apply. It applied the expression to the channel. You can see a little dot over here. That means there's an expression or a modifier affecting that channel. And then I come over here and I hit validate. It's mad at me. I did something wrong. The expression would not compile, illegal arithmetic operation or data type. A little bit of poking around through the help menus and different resources, and you're going to find out that this is not supposed to be outside the parentheses. Negative 360 times is supposed to be inside the parentheses with the rest of your equation. That's kind of how expressions work for me. I'm not a programmer. They're kind of hit and miss. You use the builder, you get a basic gist of what you want to do, you muck around with it, you look around on the internet, you look through some books. That's how you rig, because I'm not a programmer and expressions are relatively simple. So if you look at it and you can read it, it makes sense. That little fix should bring us in line with what we want to do. Apply it again if it isn't already. Nothing seems to have happened here, and that's because the plane's not moving. Let's go to frame 60, select our plane, and move it along its rolling axis. Just, a couple feet, however far you want to move it. Now let's go back to the left wheel and run the animation. Just scrub through. Yep, there it is. And if we go back to our graph editor, you can see the actual curve is moving. So we've got the solid curve, that's what the keyframes are telling it to do, and this little dashed line are what any modifiers or expressions are telling it to do. So let's do the same thing to the other wheel. Calm down. All we have to do is duplicate this and put it over there. So come down here, click clone, and you're going to get left wheel control clone. Well, that's not a very good name since we want it to be right wheel control. And very simply come through here, change every reference to left to right. Hit return. Forgot to hit return up here. There. Close the graph editor, select the other wheel, open the graph editor back up, select your pitch, go over here to your expression tab if you didn't already have it open, expressions, choose right wheel, hit apply, and wouldn't you know it, there's our graph line again. Both wheels moving correctly and independently. Okay. Each wheel got its own expression, and that's important to keep in mind, because had they used the same expression, the right wheel would have been reacting to the left wheel's position, and they wouldn't have worked correctly in any kind of swerving or turning. Also, we did some pretty simple math. We measured the distance between 2 points, divided it by 360, and the distance of the tire, and the height of the tire. We got exactly what we needed. But the math was simple, and therefore it will only solve simple problems. If you want to do some really complex turning around points, it might not rotate correctly because it's measuring the distance not from where it was in the last frame, but from where it was at the beginning of the animation. So just keep that in mind when working with expressions, and there you go. We're going to spend a little more time with our landing gear. So far they fold up correctly and they roll appropriately, but they don't compress correctly. I don't know about you, my tires in my car never have that much air in them. They compress a little underweight. And we're going to use some soft body dynamics to make these tires react to the ground. First thing we're going to need to do is jump into Modeler. We need to define what's tire and what's not. So we still have our tire up from our previous little experiment. I'm going to shift click and bring up the other tire. So we have them both up. Turn on symmetry, polygon selection mode. Select a couple of polygons. Okay, so we can see here by expanding our selection to the entire object that the wheel is not separated from the hub. If you look, all the polygons that define the center are selected as well. And that's not what we want. We want to tell the computer what's rubber and what isn't. So we're going to start by selecting some center polygons. Select all the center polygons. A little counterintuitive, but trust me, this is going to work. And then invert your selection. For those of you who don't know that shortcut, invert selection is shift quote. That will invert your selection on the current object. And now we need to look at this and say, are those the rubber part? Is that just the rubber part right there? Or did we get more? It looks to me like we got a little bit more than we bargained for. So shift close or shift open bracket will decrease your selection until we have just the part we want. That looks like the rubber to me right there. So we'll go down here and select S and select New. Let's just name this rubber. Now, for those of you not familiar with the new selection sets, it's a great feature that was added to Lightwave 8. It allows you to select a set of points or polygons and define them as a set on their own. In 7, we would have had to define this as a surface. So now we have that set up. A quick way to find out if that's true is deselect, hit W, or go to points, and down here will be our new selection. Hit plus, you can see it's right there. Save your object, jump back into layout, and let's start with the left tire again. Properties. Go to Dynamics, and welcome to the Dynamics tab, the most powerful new thing in Lightwave 8. This is soft bodies, so let's select Dynamics Soft. Click on that. Whole bunch of options here. But we have another problem we need to fix first. There's nothing for this to collide with. So let's close this. Items, Dynamic Object, Collision. Call this Ground. Now the ground is currently a roughly 1 meter big sphere. That's not how the ground works in the real world. Change it to a plane and set the radius level to 0. Okay, now the plane goes off in all distances infinitely, so you don't need to worry about the fact that it's not big enough. Let's go back to our wheel. And if we look closely, we'll see there's not going to be a lot of compressing. Our tire's not on the ground. So let's very quickly move the plane down to the ground and a little past the ground. We go back to our tire. We want to be a little below the ground. Bring the properties back up. Go to the Dynamics tab. Operators. Turn this one off. Deformation, collision detect, rubber point set. You can see just the tire lights up. Hit calculate. Now you can see what just happened. Very quickly, very easily, we now have our tire deforming as it rolls over the ground. Now, that's not very easy to see in texture. Let's go to texture shaded wire and come around to the other side. Scrub the animation that we have from earlier through, the same one we had that made the tire move, and watch as the plane moves off the ground because our frame 60 keyframe was higher up. See the compression getting more and less? Now that's not how tires compress. There's a couple things wrong. First, this is a subdivided object, and the geometry is divided, being divided before, the calculation is being run on the geometry before it's subdivided. We want to set to last. That'll smooth things out. Run the calculation again. And you can see a much smoother animation. You want to set your subpatches up to 3, and you'll really get the point. Go back to Dynamics. Right now, we have the collision size set to 0. And we can start messing around with these settings to our heart's content and really just kind of see what they do. I don't need to tell you what they do. This one's exaggerating the collision size. Let's leave that at 0. Let's go to bump. Compression bump, 0%. Now this is going to be something we want to see. It's going to bulge out the sides a bit. Keep in mind, it's only affecting our selection set, so you can see the hub is staying perfectly in place. So, let's give it, I'm going to give it, I don't know, 20% bump. Let's see what negative bump does. Doesn't do anything. Bump offset. Makes the whole tire bigger and smaller. We don't want that. Or do we? Notice when we added compression bump, it compressed both outward and slightly downward. Bump offset is a way for us to take some of that out. So offset the bump by negative, it's working out on my computer here to be 5%. Hit calculate. There we go. See the tires compressing very nicely. And then just to exaggerate the point, let's do a quick bit of play animation with our airplane. Select the airplane and keyframes on 20, 10, go to 5, move the airplane up in the air a bit, 15, move the airplane up in the air a bit. Now let's go back to that tire. Bring up the properties and recalculate. So what you're going to notice is as the airplane comes up in the air, the compression goes away and automatically comes back. It's doing exactly what we want it to. And again, set your subdivisions higher to see the effects more dramatically. Excellent. Okay, so now we've got one of the tires doing exactly what we want it to do. Now, it feels like, if you're familiar with some of the right-click options under other panels, that you could click here and choose Copy. For example, the surface editor shaders can do that. This can't do that. You have to go under here to File and select Copy. Now let's go to the right wheel, add a soft body dynamic, double-click to get the properties, go to File, and choose Paste. You've just pasted all the properties that we did before. So this should look exactly set up the way we had it. Run calculate, and now you're going to see this tire do the same thing. Very nice. So now zoom out and watch both tires deform to your heart's content. Very nice. Don't forget to go to this object that we just did, the right wheel, and set your deformation, your subdivision order to last. You may need to recalculate the simulation. There you go. Very nice. So we have our landing gear rigged. They fold up, the wheels roll, and they deform. So that's pretty much taken care of. So what other parts of the plane do we need to animate? The pretty obvious one is the prop. Now, we could use a variation on the theme of the wheel rotation. We could recycle that expression and just have it automatically rotate the prop. But sometimes that's overkill. You're using a shotgun to kill an ant. You don't need to do that. Let the animator animate this one themselves. But let me show you how you might want to tell them to do that. All right, we're going to rotate the propeller. Go forward to frame 3. Okay, now notice our wheels are still moving here. That's because they've been calculated with the old animation. When we rerun the calculations later, they'll go back to where they need to be. Just ignore them. When you start giving things minds of their own, they start behaving oddly. On frame 3, add 270 degrees to the bank. Okay, why 270 degrees? Because each frame is going to be roughly 90 degrees. 0, 90, 180, and 270. So the next frame would obviously be 360. Well, 360 can also be expressed as 0. So if we go into our graph editor, we can see that if we select the bank channel, we can see we go up to 270 degrees, and we want the next frame, frame 4, to be 360 degrees, or 0. So let's set the post behavior to repeat. Now we're getting a repeating animation. The propeller will continue to turn consistently. All right, we finished with the propeller, and now it's time to move on to some of the control surfaces. We're going to start with the ailerons. Now, ailerons control the bank of an airplane. If the one on the left goes up, that side of the plane will go down, and vice versa. And they move in opposition to each other. So we want the one aileron to do the exact opposite of what the other one does. So we're going to start by going to our right aileron and setting it up using follower to follow our left aileron. Okay, to start we're going to select our right aileron, but we want to select the right aileron root, not the aileron itself. Hit M for motion options, add a follower, double click to bring up the properties. Now we want it to follow the root for the left aileron, so aileron left root is what we're going to be following. We don't want it to do X, Y, or Z position because it'll jump to the other side. We don't want that. We don't want it to change the heading because we set that earlier to specifically take care of the rotation for this aileron. And we don't want it to follow the pitch exactly. We want it to do the opposite. So again, we enter negative and we get a nice counter rotation to our left aileron. There we go. That's how that's supposed to look. If you haven't done your homework on airplanes yet, then you can take my word for it, but that is what that's supposed to do. So now we want the left aileron to animate itself. Select the left aileron root, bring up the graph editor, and go to expressions. Okay, this expression should look really familiar. It's the one we had up here last time. That doesn't mean it's applied to this channel, it's just still kind of laying around. Click New, call this aileron control. Sure to hit return, just don't tab out, it doesn't like that. Okay, so before we did this complicated math to figure out how to rotate a wheel, this is much simpler. We're going to look into the future. We're going to look at the current frame and the frame 2 frames from now, and we're going to analyze the difference between those. And then we're going to apply that as a rotational value to our ailerons. Sounds complicated, much easier equation than before. So let's start by closing the graph editor and selecting our plane. Select the CG. We do that, we can select our proxy object. We've been doing that all along. Open up the graph editor. Select our aileron control. Delete the word value. That's just the default value. And select the rotational bank. Okay. Bank is what we want to control with the ailerons, so we want to know about the bank. Right-click and say Append to Expression. So now we have CG rotation.b. CG being the center of gravity, rotation being rotation, and b being bank. Okay, now we want to add that again, append to expression one more time. So now we have these two points in time, and I mean these two rotational numbers, they're going to be exactly the same. So let's start doing a little math. Okay, we've got our current bank of the CG now and now. We want the CG from the future. So hit comma, frame, plus 2. So now what we've got is our rotational bank of the CG right now, and our rotational bank of the CG 2 frames in the future. Now keep this number in mind. You might want to change that to your taste. We're actually looking into the future so that the control surfaces can move before the plane does, so it looks like the plane's reacting to the control surfaces when in fact it's the other way around. We want to subtract these two numbers from each other, so put a minus in between. We want to make this whole thing into one equation, so put in open parentheses at the beginning, close parentheses at the end, and it's done. Now, let's go back to close the graph editor, go back to the aileron, the left aileron root, go to the graph editor again, select the pitch. We still have our expression up, now apply it. Okay, now, nothing's happened. That's because, again, we don't have any animation. Let's select the plane and go 60 frames into the future and make a keyframe. Go to 30, make another keyframe. We're not moving it anywhere. And then go to frame 15 and bank it over to the way over to the right. And then go to frame 45, bank it way over to the left. So now our plane is banking. So the ailerons should be reacting accordingly if our expression is working correctly. Unfollow that. See how as the wing banks down, the aileron automatically comes up? and reacts accordingly. Now our other aileron should be doing the exact opposite. Let's take a look at this from behind. Better view. Very subtle. In fact, I would argue it's too subtle. So let's go back to the graph editor and add a simple multiplier. Times 10. Okay, see our graph here? Notice that the graph line, the modified graph line, actually goes into the past, frame negative 2. That's because of our pre-frame count. That means it's doing what we want it to do. Notice they're doing the backwards of what we want. So, bring up your expression, and instead of multiplying it by 10, let's multiply it by negative 10. The values will invert. The ailerons will start doing what we want them to do. Automatically animating themselves. Okay, so before it was too subtle, now it's too extreme. So instead of multiplying it by negative 10, let's multiply it by negative 3. We'll get a visible effect, but not overbearing. Very subtle. And notice how it leads the animation of the plane. All your animator has to do is fly his plane around the scene. Ailerons will take care of themselves. Very nice. And if you want to give it more lead time, instead of taking a frame 2 in the future, take a frame 5 in the future, 7 in the future, 10. It'll just react that much sooner. So that's an entire judgment call. Remember to save your scene. And that is how we're going to rig up the ailerons. Now, let's talk about the elevators. Elevators control the pitch of the plane. If they go this way, the plane's going to nose up, the plane's going to nose down. So let's recycle our expression again. Let's go to our aileron control and clone it. Call it elevator control. Now we have something called elevator control. Very nice. We want to apply it to the pitch. And now we can see that the elevators are reacting to the bank controls from the future. But that's not right. The elevator is now reacting to the roll of the airplane. It should be reacting to the pitch. So instead of changing the bank, instead of analyzing the bank, change that to P for pitch and P for pitch. Nothing changes, of course, because we never pitched the airplane. Let's select the airplane. And on frame 15, let's delete that key so our plane is flat and level. And let's now pitch it way up. Now let's go here, clear this keyframe again, and pitch it way down. See the elevator reacting? Now, because we recycled that previous code, that previous expression, our settings were all the same. Well, it turns out on this one, we don't need to invert it. So take the negative out, and I think this one's too subtle, so let's tank this up to times 6. It's doing exactly what it's supposed to do. Okay, so one more thing to take care of. That is the rudder proper. Go back to your graph editor. Go to the heading this time because we rotate the rudder around its heading, not its pitch. Clone this expression. Name it rudder control. Return. Now it wants to analyze the heading this time of the CG rotation. So we want to say cg.rotation.h for heading. Apply it, hit enter, apply. Again, nothing happened because there's no appropriate animation. Select the airplane, go to frame 15, Delete the keyframe again. Delete the keyframe at 45. Now at frame 15 and 45, just give it some wild heading changes. Way over the top. See that rudder reacting? And this time we got lucky. The rudder is reacting appropriately. In the appropriate direction, anyway. I would argue that that is a little bit much. So go to your expression, and instead of multiplying that value by 6, let's change that to 4. You can change to 3. This is a totally to taste thing. So there's our modified channel. That looks good to me. Now on frame 15, just for fun, totally throw the plane out of whack. Mess with every conceivable thing. This is just a quick demonstration. Go to your scene editor, open it, expand all these different things here. What we're going to try and do is select all the control surfaces just to make a quick point. Select the ailerons, select the elevator. Where did it go? There it is. And select the rudder. I'm just control clicking to select these. This will highlight them all in layout, and you can see for yourself exactly just how they're all reacting to their changing circumstances automatically. See how the rudder is kicked over, the elevator is kicked up, the ailerons are moved appropriately, and they're going to animate preemptively throughout the entire animation. Now, that looks good. That's exactly what we wanted to accomplish. Let's do a little bit of house cleaning, delete all those random keyframes. If you don't know how I'm jumping through the keyframes real quickly, it's just Shift and the left arrow key or right arrow key respectively. And now we are getting very close to the fun part, which we'll do next. Okay, so we've gotten a lot done so far. The gear fold up, the wheels roll, the wheels compress, the control surfaces react accordingly, we can select our center of gravity easily, we can animate our plane when it's on the ground. A lot of mundane but important things. Now there comes some fun. Let's get those guns to fire. Let's start shooting some bullets. This involves some particle effects and is surprisingly difficult compared to how you'd think it would be, but it's not insurmountable. So let's get started. First thing we want to do is go to Items, Add, Dynamic Object, Particle. It's kind of misnamed if you ask me, because it's not a particle we're adding, it's a particle emitter. We're going to name this one Left Gun. Emitter type, hypervoxel emitter. The other kind is a partigon. Lots of uses, none of which we'll be covering now. We're going to start with hypervoxels. Immediately brings up its properties. Let's close those out. Bring back up our quad view. Let's take our emitter and move it up to over our left gun. We want this to be pretty accurate because we definitely want the bullets coming out of the right place. We don't want our particles emitting back here and being seen through here. We want them to emit right here. So that's relatively good. Let's bring up the properties. Go to Dynamics tab if it doesn't automatically go there. Double click to bring up your particle properties. Okay, the first thing we need to do is make the generator smaller. We need to make the generator no size at all. So set all of these to 0. Particle limit, don't mess with that. Size effect. Okay, we just changed the size to 0, and the size was set to density fix, which means the particles will be less dense. In fact, they will have no density. We don't want that. Set the size to no change. The emitter is a sphere. That's fine. Generate by second. Okay, we want to generate by frame. I want to shoot roughly 15 particles a second. You'd think that would be 0.5 particles per frame. Actually, what appears to happen when you get underneath 1 particle a frame is it actually begins to act like a chance. If you set it to 0.5, you've got a 50% chance of firing a particle. I would hope that it would behave like every other frame. It doesn't. If you set it to 0.1, you've got a 1 in 10 chance a particle's going to come out. That means on each frame it'll roll the dice, and if you hit that number, you're going to get a particle. You can get 1,000 particles in a row and then none for an hour. Unacceptable. We're going to have to fix that. So for now, just set it to 1 particle per frame. Let's set this to 120. And let's go over here to motion. Let's set the velocity to 10 feet in the x-axis. Press play. Okay, obviously the x-axis was not the right axis. Don't press stop, let it keep playing, change that to 0. Change it to z. Now we've got particles coming out the front of our gun. They're not going very far, and they're not doing very well. So let's speed them up. 10 feet per second is just not fast enough. Set it up to 1,000. Now we're cooking. In reality, we're still not going that fast. But I think that's about right for our purposes, speaking artistically. If you want to jump on the internet and look up how fast the bullets from a 0 went, have a good time. But this is the part where we get into a little bit of artistic freedom, if you will. Another artistic freedom is the fact that these are hitting our propeller blades. In reality, the plane would have been geared in such a way that the propeller would never be hit by a bullet. Don't worry about that little fact. Motion blur will cover that little mistake. If anyone's watching your animation that closely, good for them. So now we've got the particles going where we want them to go. We want to add a little bit of gravity. Alright, I'm sure you've heard this in every tutorial you've ever seen or read, but natural Earth gravity is negative 9.87 meters per second squared. I have this set right now to English units, so it translated that to feet for me. Press calculate. Now, 2 interesting things just happened. First of all, I used calculate. So if you were paying attention, you noticed that our wheels, who had a mind of their own, are now behaving correctly. Second of all, the particles shot off into the distance and fell at a relatively realistic pace. And then if you notice, way out there in the distance, they're bouncing. You might not be able to see that on the screen, so I'm going to move out there. The ground plane we created for the wheels to collide with is causing our bullets to hit the ground. Now, we could solve this problem, but it's really not a problem, is it? Because the bullets would hit the ground, wouldn't they? So let's not deal with that, but it's something to be aware of. So I personally think the particles aren't living long enough. This is something that can be changed. It's entirely to taste. Let's change it to 120 frames. That means for every time a particle is born, it will live for 120 frames, and then it will die. They're going to go way further out there into the world. That's okay. When we're up in the sky, we'll want that. We might want them to not live as long. Depends on the need of your scene. You can always just come here and change it. Particle weight is 1. I don't care about that. I care about this, plus or minus. I'm going to add 0.1. Now means each particle will have a random chance of being 1, 1.1, 0.9, or anything in between. Adds a little randomness, always a good thing. Okay, calculate again. Kind of subtle, but it's definitely having a little bit of a change. It'll have more of an effect in the air. Now, let's go to etc. Positional blur is 100. Good. Most parent blur is 100. This setting can be a headache. We want it to be 100 right now. It means the particles will be born inheriting all of their parents' motion. In this case, the plane is flying through the air, and so the bullets are being fired. If we had 0 parental motion involved, they would only have their own predetermined 1,000 feet in the z. So if the plane is going a certain speed, the particles would be emitted in the right place and then go 1,000 feet per second. Okay, what if the plane's going 1,000 feet per second? It's a really fast plane, but, you know, track with me for a moment. Plane's going 1,000 feet a second, bullet goes 1,000 feet a second. They're going to track with each other. If you have parental motion set to 100%, it will inherit all of the parent motion and then it will add to that its own motion. So if the plane's going 1,000 feet per second and you have 1,000 feet per second set up, they add to each other, 2,000 feet per second, bullets come out the front. You could argue me the physics that might not be the most realistic thing in the world, but for our purposes, exactly what we want. Okay, so we have no explosion and no vibration. Vibration is how much the particles kind of dance after they've been created, and explosion is how much variation from the original trajectory they have. I want this to have a little bit, just to mix, again, to mix things up. Very subtle. I'm going to change it to a higher number. If you hit calculate instead of play, hit control to stop it. I'm going to use play right now. Now it's going so fast you can hardly notice it, but if we turn down the Z-axis, you get a much better view of the bullets coming out. Kind of a pathetic little bit of bulletry right there, but you get the idea. See how they're broken apart right here? That little bit of randomness is going to be nice to have later. Add a little bit of vibration, and you get all sorts of craziness. That's obviously a bit much. I'm going to go with 2 and 1. Judgment call. Put this back up to 1,000. Looking pretty good. Now, let's deal with one problem at a time, and our current problem is that we haven't parented that gun to our plane. So let's do that now. Motion options, parent, fuselage. Now when we animate our plane, our gun comes along for the ride. Just to illustrate the point, we're going to make our plane fly up into the air and do a bit of a turn. Just a little bit. This is really bad airplane animation, just to make a point. Now, go back to the gun, the left gun, properties, calculate. Plane travels, gun fires. Okay, now that might look a little bit weird. What you're seeing is a frame inaccuracy that'll be fine in final animation. Right here, you see the trail coming off the bullet, making it look like it came out of the airplane from below. The trail is just shooting back along the particle's current trajectory. So this particle is here. It was fired in the previous frame. And so that's why the trail is actually pointing back to where it was fired from, not where the gun currently is. It'll mess with your head a little, but it's exactly right. So don't get too concerned about it. Let's delete that animation. And very quickly we want to go back to our gun, clone it. I'm going to hit Control-C, number of clones, 1. Okay, T, go to the position. Take out the negative, and now you've added a gun to the other side of the airplane. You can see it up here. Go to the scene editor, and our new gun that was just added is up here. Left gun number 2 is our second gun. We don't have 2 left guns, we have a left and a right gun. So rename left gun to right, left gun 2 to right gun. Hit return, we now have left and right guns. There you go. So now how do we control the firing on these? Well, my solution is to create almost a firing mechanism. There's a lot of different ways you can do this, but sometimes I like to think about things mechanically. It really solves problems well. So what I'm going to do is I'm going to create a new null, and it's going to just kind of pulse. It's going to pulse in 2 rotational axes, the heading and the pitch, from -1 to 0, and then -1 to 0. Each rotational axis will control when a gun fires. We're going to set up a quick expression so that when the pitch is at 0, the left gun fires, and when the heading, or when the bank is at 0, the right gun will fire. So, it sounds kind of complicated. It's really very simple. Let's do it. First thing to do, another null. Imagine that. Let's call this gun timer. Move it, parent it to the CG or the fuselage. We're really just trying to get it out of our way. Move it up out of the way. Okay. Make 6 quick keyframes without changing anything at frame 0. It's a given. 1, 2, 4, 5, and 6. On frame 0, set the heading to -1 and the pitch to -1. Do the same for frame 2. You could also just copy these keyframes or create the keyframe at 0 and just copy it all around. This is just my preferred way of doing things. -1, -1, and do the same thing in frame 6. Okay, so we have entirely unanimated, or partially animated null. Now, on frame 1, we want the values to be -1, 0, 0. The pitch just went from -0 or -1 to 0 and back. Remember when I said the pitch is at 0, one of the guns will fire? There you go, the gun will fire on frame 1. Now we want to make frame 5, 0, -1, 0. Go to the graph editor. Might make it a little more clear what's going on. Okay, when this peak is here, it'll fire the one gun, this peak will fire the other. Select them all for me. Go to curves and set their tension to 1 so they don't go into the negatives. And so we have a gun firing on frame 1 and on frame 5. Now how do we make that happen? First, we save our scene. We've been working a little while. Bring up your graph editor. Go to your heading, which is controlling one of your guns. Go to expressions, new. Let's call this the left gun control. Let's just call it left trigger. That's more fun and it's very clear. Under value, delete the word value. Right click on our rotation heading and append to expression. Now we have gun timer rotation heading as part of our variable. Now we want to go to our left gun. Go to the properties, double click. Now right next to birth rate, it currently says 1, and there's an E for envelopes. Envelope just means that you can animate this particular variable through the graph editor, and anytime you see an E, that's what it means. So we want this to be 1 plus gun timer rotation H. Now, that's the world's most simple expression. Let's see if it worked. We can zoom in forever, but you can see here that the expression now follows up and goes to the 1 point on frame 5, like it's supposed to, and comes back down. All we did was add the value of 1, as in particle per frame, 1 particle per frame, plus the rotation of H. If you remember, the rotation of H was -1 at all times, except when we wanted the gun to fire. So 1 plus -1 is 0, no particles. And then on frame 5, it goes up to 0, 1 plus 0, 1, fire a particle. But you see it only fires once. Well, that's no good. So let's go and go back to our gun timer. Bring up the graph editor. Select, using the shift key, my rotation and pitch channels. Hit shift A, brings them up. Now that we have them both selected, set the post behavior to repeat. Now we've got a problem. See how the one channel is repeating unevenly. We need the pitch to wait a little while longer before repeating. So let's add a keyframe at frame 7. Just double tap return. And that keyframe at frame 7 should be 0. So right click drag, select all of those keys, and set the value to -1. Okay. Right click drag, select everything just to be consistent, set the tension to 1, and now we see it's not exactly evenly spaced yet. Select your frame 7 keys and slide them over 1 frame to 8. And now we have the pulsed timing we want. Gun 1, gun 2, gun 1, gun 2, etc., so forth, in nice Christmas colors forever. Okay, that done. Come out here. Go back to our gun, our left gun. And now let's see if our little creation is working. Perfect. See, our left gun is firing at a relatively slower pace, consistently, but not on every frame. Our gun on the right still has its emitter settings set to 1 per frame. See how that repeats. So we've got we're very close to what we want this to be doing. Let's go to the other gun. Let's go to the right gun. Double click, click on its envelope, and let's go. We've got our expressions bin open. We've got the left trigger. Go to expressions. Let's clone that. We'll call it right trigger. And change this from rotation heading to rotation pitch. Hit return. I forgot to hit return up here, my mistake. And let's apply this. Now calculate again. It's kind of hard to tell because the one is highlighted and the other isn't, but if we were to shift select both of our guns and run that same animation, left, right, left, right, left, right, left, right. A little rough to tell exactly what's going on, but you get the idea. If you look straight down between them, you can see that it's left, right, left, right. Okay, so we set up a firing mechanism, and we have our guns firing at less than 1 frame, or less than a shot per frame, but controllably. And that control is really important. Now, mind you, let's say for dramatic impact in your scene, you want to fire those guns more quickly or more slowly. You can change the speed at which the gun timer fires by going to the scene editor, opening it up, selecting your gun timer, and see these little dots here in the new scene editor. Click and drag them. Those are keyframes. You can literally just drag them out and slow them down. And it'll slow it up. I'm going to undo that right now because that wasn't good. But you get the idea. It'll slow it down. Or you can speed them up. Your choice. But it gives you a lot of control. And by setting both timer variables to different channels of the same object, you don't have to mess with more than one object to change the timing. All right, save your scene. Okay, so now the guns are firing, and one of the most dangerous things in the world is a gun that fires all the time without stopping. So now we've got to figure out a way to stop the guns from firing when we don't want them to. And to do that, we're going to add another null that we're going to call our trigger. Now, we could start it by adding a new null, moving it into place, adding the custom shape object, and all that jazz. We've already done a lot of that when we did our gear control. So let's just clone our gear control. By doing this, our parenting is taken care of. Our custom shape is all but taken care of. Just scoot it over a bit. Go to your scene editor. Right-click on your new gear control 2. Rename it to trigger. You can call it gun control if you want to be consistent, but I'm going to call it trigger. More fun. Bring up the properties. Go to the item shape under custom object. Change the colors. We don't want it to look exactly the same. I'm going to give mine kind of an intimidating yellow, I suspect. There it is. And change the text color to black. It's a neat little trick I just did. If you don't know that trick, right-click and drag on the color box, and you can change the saturation of the entire thing by changing all the variables at once. And it's not the gear control, it's the trigger now. So change that name, hit return. We're done. Now remember, this is rotationally locked to only go between 0 and 90. Let's use that to our advantage right now. Let's go to our gun timer. And now our gun timer is going to get an expression. Graph editor. Go to our heading channel. And new expression. Also in trigger pull. Now we want to go and get a variable from our trigger. So let's select the trigger. Trigger's selected. Go to the graph editor. By the way, if you don't like closing and opening the graph editor this much, there are options for that. Graph editor options. You can choose all sorts of different things here, but you can track layout time and track item selections. Now you don't have to close your graph editor. You can just select different things and your graph editor will follow you. So that's kind of nice. So now with our trigger selected, we're going to right click or click on the pitch. You can see that we have our jump in our curve here from 0 to 90 on frame 30. So we know we're in the right place. Right click, append to expression. So now we have value and trigger rotation. So let's put a minus there, value minus trigger rotation. And let's go back to our gun timer. Let's go to our heading. Zoom in a bit on that. And let's scroll over to make sure we can see frame 30 because that's where the action is going to be. We want to make sure we can see that. So now we have frame 30 in our view. And let's apply this. It's not going to be right, but let's just see what we're starting with. Okay, so on frame 32, we can see the value drops all the way down to -90. That is because what we're doing here is taking the current value, which means the keyframe value of this channel, and we're subtracting the rotational pitch value of the trigger. The trigger is going all the way to -90, so you minus 90. That's too far. We want the value to minus 1/90th of 90, or 1. So let's just divide that by 90. It's easy enough. Open a parentheses, add a divided by 90, and close the parentheses afterward. Now it's only subtracting 1. Okay, but that's not right. When it's at 90, we want it to be firing, not firing. We need to invert this. Okay, so we've got the value subtracting 1/90th of 90, or 1, and that's backwards of what we want. So we actually want it to subtract the opposite of that. So let's add 1 minus. So now we're saying current keyframe value minus 1 minus 1/90th of that pitch. That sounds really complicated. It's actually not. Hit return, and the frames start doing exactly what we want. Before the frame rotates over to 90, we are never exceeding -1. So the frame is doing correctly. And after frame 32, we are popping up exactly when we want to be. So what we're doing is the current frame value subtracting 1. So the current value was -1, so now we're down to -2. Now we're subtracting again 90 minus, or divided by 90, so that's 1. So we've got 1 minus 1 minus 1. It all works out in the end to look like this, which is exactly what we want. So if I'm sane, and I think I am, when we recalculate this animation by selecting one of our guns and calculating it, it will only fire after frame 30. There it is. We've only been working with the left gun, so the right gun is firing the whole time. If we select the left gun, you can see it doesn't start firing until frame 30. And there's frame 30. So now we need to fix the other half of the gun timer. Select the gun timer, back to the graph editor. We now have a working expression on the heading. Let's add another working expression to the pitch. Just select it, with trigger pull still selected, hit apply. Now our trigger is controlling our guns. Nothing's firing. There's frame 30, and there's the firing. The guns are alternating, they're only firing when we want them to, and we have full control over them with the trigger. Just to prove that, I'm going to stop the guns from firing on frame 60 by adding a keyframe, and then on frame 61, I'm going to take out all of that rotation. Calculate the simulation again by selecting one of our guns. The guns will not fire for 30, and then stop firing. There's frame 30, there's frame 60. Watch it a little more slowly, you'll see that's exactly what we want to have happening. Frame 30 comes across and they start firing. Unfortunately, it looks like we've lost a little bit of our control. Now let's take a look at our expression and figure out exactly what just happened. Go back to the gun timer. Now if you go to your expression bin and you select trigger pull under expressions and you hit get expressions, it'll get the two channels in question. So now let's look what's happening. Let's select the heading. We can see it's happening on both of them. CR control are modified here. It's doing what we want it to do. It's doing what we want it to do. And then it's doing this weird curvy thing. So who's the suspect there? That's the trigger. If we go to the trigger control, or the trigger, and we look at its graph editor, for pitch, we didn't lock those down. And when it got over 90, the math got weird and it fell apart on us. Simply go and set these all to stepped and everything will fix itself. It's that kind of thing that can get you in trouble. Losing track of those little details will get you all mixed up. But now it's firing exactly like we want it to, reliably and controllably again. Okay, so we've rigged the landing gear. We have them moving up and down with one null. We have rigged the wheels to rotate automatically. We have them deforming. We have the guns firing, the props spinning, the control surfaces animating themselves. We have a bunch of nulls we can select to get the plane to move how we want it to. And we have the hypervoxels rendering. So what's left to do? Well, we need to play with our new toy. If the technical director doesn't spend a little time playing with his new toy, the animator might find some surprises. So let's put together a really quick scene, quick takeoff, fire the guns a little bit, set up some cameras, call it a day. We're going to start by putting our camera in a better place. Select the camera, move it wherever you want. I'm going to get up a little bit ahead of the plane, looking back at it. Okay, I'm not going to spend too much time playing with the camera because we're about to start moving the plane. So let's select this null between the tires that we'll remember from earlier is the wheel center. Okay? While we play with it, think about how it would make life easier for the animator if we changed certain things as we went. For example, there's this random null floating between the tires that we know what it is. It's not labeled and it doesn't have any shape to it. So we're going to add a real quick custom shape. This is why you spend a little time playing with your new toy to make sure that it has everything it needs. Now let's do a ball. Draw a line to the CG, give an idea of what it does, label it, ground control, make the selected color blue, why not? Unselected color, make it a brown for the ground. Again, why not? There you go, ground control. Okay, start animating our plane. We need to put that rear wheel on the ground. Quick little rotation of the ground control puts the wheel on the ground. Okay, now ground control should only be used to rotate the plane. So let's go to translate and turn off all these positional things. We don't want the animator accidentally using the ground control to move the plane. That's what we use the CG for. The ground control just rotates it as if it's on the ground. So let's move the plane. Let's go to frame 60. Move the plane forward a little bit on the ground. Okay, the wheels fell off. We know why they did that. We discussed that earlier. And now just to make things a little more interesting, let's go to frame 30, move the plane a little off that path. And here's back where the ground control comes into play. Reselect the ground control, rotate it to face in that direction. Plane will roll up to that position, and since there's no keyframe there, it'll stay in that position. We don't want that. So now we're here. Let's take that heading back out. No tricks here. This is just normal animation stuff. Mark that key. Frame 45 probably should be pointing a little more along that path. This is quick and dirty. This is not, by anyone's definition, good animation. You notice what happened there? We forgot to do house cleaning on the trigger, and now the guns are firing starting on frame 30. We'll take that out in a moment. Put them here a bit. Our plane should be moving okay. Okay, again, we're just playing. I'm going to add a couple hundred more frames here. Take this out to frame 450. Completely arbitrary number. And I'm going to go out to frame 150, or let's call it 200. Select the plane. Move it down the runway quite a bit. We're getting up to runway approach speeds, or takeoff speeds. Go to frame 200, take your camera, point it at the plane. Now, let's go back to our ground control. As the plane gets up to speed, those wheels are going to lift off the ground. That rear wheel is going to lift off the ground. So rotate the plane back up to a takeoff attitude by setting the pitch back to 0 on frame 200. So here's what we've got so far. Plane rolls around how it's supposed to. Might want to make some tweaks to the camera, make sure it's pointing at it the whole time. Frame 150. Fewer keyframes you use for a camera, the smoother it'll be, so just don't do too much messing with it. Rear wheel starts to lift off the ground. Frame 200 happens. And on frame 250, let's get this plane off the ground. But I want to keep it moving at a consistent pace. So let's go to the graph editor, set our post behavior for position, and rotation even. Let's set all of our post behaviors to linear. That means they'll maintain what they were doing when you stopped animating them last. So we have just recently set a speed for it. So if I were to go frame 250, it will have continued down just as far, except that I made those changes to the camera on accident. Make those changes to the CG. Go to frame 250, it's further down the runway. This time, lift it into the air. We're starting to fly. Pitch it back a little bit. It's the first animation we've done for the CG when it comes to rotation. So you're going to have some issues with your function curves. Jump into the graph editor, clean them up. Again, simple animation. Comes around the corner, tail lifts up, takes off into the air. Very nice. So what's it going to do after it gets into the air? It's going to keep flying. It's going to bring up its landing gear. So let's select the gear control. You can select it all the way from out here because of those custom objects we added earlier. And add a keyframe at frame 250, now that's in the air. Go to frame 300, because we want them to come up slowly. Again, these are all completely arbitrary, just test animation. The gear came up exactly like we wanted them to. Go to the graph editor and strengthen all those curves, increase the tension on those. Otherwise, it's going to accidentally start to overexpand and then come up before you take off. Let's gear her down. Take off. And the gear come up. Plane's continuing to fly exactly as we want it to. Now, let's go fix those guns. Let's select the trigger. And now that we're in the air on frame 300, we can start doing some firing of those guns. You don't want to fire the guns on the ground, dangerous. Go to the graph editor and select your pitch heading. We've already got some keys in place. We could delete those. We could add them back in. Let's just move them. Scoot them over by using the frame, right drag on all of them, and then scoot them over to frame 300. I wanted to fire the guns for a little longer. Take those out to a little less than 400. Okay. Now we've got extra keyframes down here. What are those? Well, we only moved the pitch. We left the other channels alone. Let's clean them up. Just delete any keyframe that isn't frame 0. We don't need them on every channel that isn't pitch. Good. Plane rolls up, takes off, starts firing its guns. Camera, of course, tracks it into the wild blue yonder. So make sure your camera keeps pointing at it. There you can see it firing its guns. Very nice. Recalculate the gun simulation real quick, just to make sure it's only firing when we want it to be. Dynamics, calculate. You'll also see the tires fix themselves. Let's get a bigger view of this, just so we get all the little details. Get this out of your way. Interesting thing it does. It's thinking about so many different things. Soft body dynamics, particle effects, all these other things that, to save memory, it gets rid of the plane and only shows you what it's really working on. And that's our animation so far. Now, we really didn't do very much in the way of making the plane dance. Let's add another camera. Under Items, Camera. Let's call this one Camera 2. Let's go to frame 300. And let's move this camera out toward the plane. Just because we want to... In fact, let's be more clever than that. Let's go back to frame 0. Let's glue this camera to the plane just behind it. A little chase cam action. Parent it to the CG. Now run the animation. What's going on there? Kind of a boring camera angle. It looks like a good camera angle because it's glued to the CG and the CG isn't rotated and the wheels are. That's why we have this little off view here that isn't accurate. So let's get even more off center. Good little view. Animate it. You can see the wheels are turning and deforming. We take off, bring up the gear, fire the guns. Very nice. Okay, now let's add a couple of maneuvers to the airplane. Specifically because we want to see those rudders and elevators work. Go to frame 300. Kind of rolling, flying out here. Just brought the gear up. Add a keyframe. Get it pointing along its path a little bit. You see when you add the rotation, you get the tail, the path comes up here. Line the plane up to its path a bit. Go to frame 350. Add another keyframe. The path shows up. We're pointed along it. Very nice. Add 360 to the bank. We're going to do a barrel roll. This is going to be great. Now, because we have things set to continue on afterward, for our animating convenience, we're going to go to frame 400 and make sure that the bank is still 360. That'll stop the barrel roll. Okay, so we've taken off. And we start that barrel roll, watch the ailerons work, and they come out. And if you look off during the takeoff, you can see the rudders working, the elevators working a little bit. But let's make them work a little better. Go to frame 200. Now I've already done this, but I'll show you what I did. Now the plane needs to pitch up so it can take off. So go to frame 215 and pitch, or 214 in my case. Pitch the nose up a little bit just after takeoff. So it's kind of pointing skyward, a little exaggerated. This will give the the elevator something to do. Watch them kick up there and then push the nose into the sky, and we're doing exactly what we want. There we go. Now the bullets and the wheels aren't behaving correctly. We know why that is. Let's run that simulation one more time. Select anything that has a simulation on it. The guns, the wheels, anything. Bring up the Dynamics tab, hit Calculate. Watch the wheels deform. Rotate. Now, how cool is that? See how easy that is to animate? Let's create a quick preview and see what that looks like. We can edit this part out. Okay, let's take a look at our animation in real time. Look, the propeller spins very nicely. Okay, so that's 450 really good frames of animation. Lots of complex stuff going on automatically. Guns are firing, gear is folding, flaps are moving, a lot of stuff getting done by itself. Really good scene, lots of good things going on. So now what do? We look at the scene as an animator. What else do we want in there? Do we want some more controls? Do we want a way to take care of that back tire that's just sitting there not doing anything? Think about it from there and really try and plus the scene. Add some things that'll make it easier to do. Now, why would we go through all this much trouble for 450 frames of animation? In short, we wouldn't. We go through this much trouble for 10 scenes or 15 planes. When there's a lot going on, this kind of prep work will save countless hours in a production environment. Definitely time well spent, even if it doesn't feel like it at times when you're going through and naming your 15th layer. So in our next DVD, we're going to take this airplane, fly it around, and blow some things up. Really have some fun. More particles, some cloth simulation, lots of good stuff. So I'll talk to you then.